I, Gurmeet Singh, welcome you to the Creator classes and also welcome to our lecture series on permutation. And this is the fifth lecture under the permutation series. We have a series of lecture on the various topics of the permutation. Refer our YouTube channel for the complete videos on the various topics of permutation, including the question series and also the assignment. Apart from this lecture series on permutation, we have a series of courses on various mathematics topics. Refer the link in the description. The detail we will cover at the end of the video. So without taking any further time, let's begin with this video. Best of luck. In this lecture, we will see the special cases or the special conditions in which we combine some of the letter or we club some of the letters. So basically formulas and the fundamental will remain the same, only the logic will change. I always say the permutation, combination and the probability are logic driven fundamental. These are not formula driven fundamentals. The technical formulas are very simple. Only the thing that matter in the examination is your logic. If you are able to, decode the question, what the question framer is asking, you can easily solve the question. So in permutation, combination and the probability, the focusing on the question is very must. Okay. And in this lecture, we will cover the special conditions in which the clubbing of the item will be there. Okay. So let's see what I am talking about. We will directly start with the questions because the fundamental and everything we have covered in the previous lecture. Only the special conditions question we will take. So let's take our first question. The question is, find the number of different 8-letter arrangement that can be made from the letters of the word daughter. So that first, all vowels occur together. Second, all vowels do not occur together. Okay. In this question, we are having a word daughter. That is a 8-letter word. So basically we have to form the various 8-letter arrangement that we can form using the word daughter. And two conditions are given. In the first condition, we have to put all the vowels together. And in the second condition, we have to put all the vowels not together. So basically this is two questions. So let's approach this question. First of all, we have to segregate the vowel. What are vowel? A, E, I, O, U. These are the vowel. And if you see the word daughter, we are having the vowel as A, U and E. Okay. In the first case, we have to put the letters A, U, E as together. And in the second case, these letters should not come together. Okay. So firstly, we will see what are the various 8-letter arrangement that we can form from the word daughter without these two cases. Okay. We will apply simple our formula of the permutation. 8 letters are given and we are having 8 vacant places. So our answer will be 8 factorial. So basically we can form 8 factorial words using these 8 letters. Okay. So we got our answer as 40320. That is the value of the 8 factorial. No need to remember it. Further, let's take our first case. That is when all the vowels are together. It means that A, U, E should be together. Let's capture these 3 words together. Okay. It means that wherever we put these 3 words, it should be together. Like we can put this word in the first place or in the second place, in the third place. Wherever we will put these 3 words should be together. In other sense, we can say these 3 words are a combination of a block. Okay. So for the time being, can we say A, U, E as a single block or a single letter? If we say A, U, E as a single letter, then we can say this is a 6-letter word. Okay. What we have done, we have combined A, U, E and we are saying A, U, E as a single letter. Okay. We know it is not a single letter, but for the time being, for the sake of the question, we are saying it as a single unit. Okay. So if we say this as a 6-letter word and we are having 6 slot, so we can form 6 factorial arrangement. Okay, n equal to 6, r equal to 6. So basically we can form the 6 factorial arrangement or the permutation using these words, and where A, U, E is considered as a single block. But within this block, that is within the block of A, U, E, these 3 letters can be rearranged. In the question, it is given the vowel should be together. That is the condition, that is A, U, E should be together. But AUE can rearrange among themselves. Like AUE can be EUA or UAE, anything can be formed. So what are the various number of arrangement that AUE can individually form? That will be 3 slots and 3 letters are given. So that will be 3 factorial. Okay, 6 factorial when we are taking it as a combined, and within this block of vowel we are having 3 factorial arrangement. So our answer will be 6 factorial into 3 factorial. That will be 4320. Are you getting why we have used a multiplication? Because if you apply the concept of OR and AND, here AND will be applicable. That is the arrangement of AUE and the arrangement of the total letter. So here the multiplication will be used. Got it? So our answer will be 4320. Now let's move to the second case where all vowels do not occur together. It means that we cannot put AUE as together. So what will be the number of cases that we can form? It will be equal to the total cases that we can form from the letter daughter, that is 8 factorial, minus the cases when all the vowel are together. Got it? Total cases minus the cases when vowel are together will be equal to the cases when all the vowels are not together. That will be equal to 40320 minus 4320. That is equal to 36,000. That is, we can form 36,000 arrangements where all the vowels are not together. Okay? Just repeating the last step again, what we have done in the last step. Firstly, we have calculated the total number of arrangement that we can form using the word daughter. That is a 8-letter word. Okay? That is 8 factorial. So we have calculated we can form total 40,320 arrangement with the 8-letter word, that is daughter. Then we have calculated the total number of arrangement that we can form with all the vowels as together, that we have calculated as 4,320. Okay. In the last step, we have to calculate the total number of arrangement that we can form when all the vowels are not together. So what we have done? We have subtracted the total number of cases where all the vowels are together from the total number of arrangement from the word daughter. Okay. The remaining will be the arrangement when all the vowels are not together. This is the case when all the vowels are together, and this is the case when all the vowels are not together. Getting the fundamental, all the concept and formula are same that we have covered in the previous lectures. Just the thing that is applicable in this question is the basic logic. So again repeating, in the questions of permutation, combination and the probability, only the thing that matter is only your basic fundamental, the basic logic. The formulas are very simple. If you are able to find the basic logic in the question, you will go through the question. Okay? Slightly a tricky question, but these type of questions are generally asked in the examination, where you have to block some letters or some items together and you have to calculate the permutation by taking that block as a 1. And within the block you can solve for the permutation, and finally you have to multiply because AND will be applicable, and AND means multiplication, that we have covered in the lecture of the counting. Okay, let's take one more question. The question is, find the number of arrangement of the letter of the word independence. In how many of these arrangement? First, do the word start with P? Second, do all the vowel always occur together? Third, do the vowel never occur together? Fourth, do the words begin with I and ends in P? Large question, 4 options are there and you have to solve it. Take your time, pause the video and try to solve this question. Note that only logic will be applicable in this question. All the formulas and the fundamental we have covered and you know it. Okay, only you have to apply the basic logic to solve this question. Okay, pause the video and try to solve this question. So let's approach this question. We are having the word independence. Okay, it is a 12-letter word. So firstly, let's see what are the various arrangement that we can form using the word independence. So it is a 12-letter word and we are having 12 vacant places. So we can form the 12 factorial arrangements. But if you note the word independence, here the letter N is repeating 3 times. the word D is repeating 2 times and the word E is repeating 4 times. And in the previous lecture, we have covered how to deal with this question. We have to divide 12 factorial with 3 factorial as n is repeating 3 times, and we have to divide it by 2 factorial as D is repeating 2 times, and further we have to divide it by 4 factorial because E is repeating 4 times. Okay. So on solving, we got our answer as 1663200. This is the number of arrangement that we can form using the word independence. Got it? Now let's see what are the various conditions given in the question and how to tackle these conditions. The first condition, do the word start with P? Okay. So we are having 12 slot and the first slot or the first word should be P. So basically if the first slot has been booked by P, we are left with 11 slot and we are having 11 letters. So 11 letters and we are having 11 slot. N is repeating 3 times, D is repeating 2 times and E is repeating 4 times. So our answer will be 11 factorial upon 3 factorial into 2 factorial into 4 factorial. Got it? The first letter has been consumed by the letter P. So we are left with only 11 slot. Got it? Simple logic. Second, the second condition is that do all the vowel always occur together. So firstly we have to locate the vowel. So in this word independence, the vowel are I, E, 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 E. Okay, only 5 vowels are there. E is repeating 4 times and I it is only 1. So these vowels should come together. Okay. So we will apply the fundamental that we have used in the previous question. Here we will consider this unit of vowels as a one set or as a one block. Okay, so basically if we consider this as a one block or as a one letter, we will consider this as a 8 letters. Okay, 7 this letter and 1 as a set, so it is having total 8 letters. So we can form total 8 factorial arrangement and we have to divide it with 3 factorial and 2 factorial because N is repeating 3 times and D is repeating 2 times. Okay, if we consider all the vowel as a one unit, then these number of arrangement we can form. And further, within this vowel, how many arrangement we can form? Like we are having 5 letters and E is repeating 4 times. So basically we can form 5 factorial upon 4 factorial. Why 5 factorial? Because we are having 5 letters and we are having 5 vacant places. And we have divided it by 4 factorial because E is repeating 4 times. And we have to multiply both of these numbers. So we got our answer as 16800. Okay, these number of arrangement we can form when all the vowels are together. Further, let's move to the next condition. The condition is, do the vowel never occur together? Okay, the same thing we have discussed in the previous question. When all the vowels will not be together, that we can calculate by subtracting the number of cases when the vowel are together with the total number of cases. Here the total number of cases we have seen as 1663200 and we have to subtract the number 16800. So we got our answer as 1646400. Okay, that is the answer of this question. Further, let's move to the last condition. The condition is that do the word begin with I and end in P? Okay, it means that the first letter has been consumed by the letter I and the last letter has been consumed by the letter P. So basically we are having 12 letter and 12 slot and first and the last slot has been used. So we are left with 10 letters and 10 slot. Simply we can apply our permutation formula, that is 10 factorial upon 3 factorial into 2 factorial into 4 factorial. Okay, here N is repeating 3 times, D is repeating 2 times, E is repeating 4 times. So we got our answer as 12600. That is the answer of the question. Okay, got it? Slightly a tricky question, lengthy question, but this question is very important. It is clearing all your fundamental related to the clubbing of the letters. Okay, so let's move to the next question. The question is, in how many ways can the letter of the word permutations be arranged if there are always 4 letters between P and S? Okay, a slightly more trickier question. take your time and try to solve this question. Okay. Let's approach this question. We are having the word permutation. Basically, it is a 12-letter word. Okay, permutations. And we have to form the number of arrangement that we can form where there is always 4 letters between P and S. Okay, this is the condition that is given in the question. So firstly, let's see what it means, what it actually means. We are having 12 slot. If we put the letter P in the first place, then we have to put the letter S in the 6th place, because we have to leave 4 vacant places in between P and S. Okay, this is a condition which is given, that is there should be 4 letters between P and S. Either S can come here or P can come here. Okay. So first of all, let's see what are the various cases in which there is a 4-letter difference between the letter P and S. The first case we have seen. In the second case, the P can come in the 2nd place and S can come in the 7th place, or S and P can rearrange among themselves. And in the third case, P can come here, S can come here. In the fourth case, P and S can use these slots. In this case, P and S can use this slot, in this case and this case. So basically we can form 7 cases where P and S can use a slot where the 4 letters lie between P and S. Okay. And we have to separately solve all these 7 cases. And in the end, after solving all these 7 cases, we have to add them, because either the first case will be applicable, or the second case will be applicable, or the third case will be applicable, or, and we know what is or means. Or means addition. So the fundamental of the counting will be applicable here. That is the concept of or and. Okay. Or mean addition and means the multiplication. So let's actually solve this question. So let's take the first case in which the P and S can use these slots. So let's see what are the various number of arrangement we can form. So if we fix P and S in this place, we are left with only 10 vacant places and we are having 10 letters. So we can form 10 factorial arrangement. And if you observe the word permutation here, T is repeating 2 times. So basically we can form 10 factorial upon 2 factorial arrangement using these words. Okay. Note that the position of P and S has been fixed and we are left with only 10 vacant places and we are having 10 letters. Okay. So our answer is 10 factorial upon 2 factorial. One thing to be noted here is that P and S can interchange their position. Means P can come in the first place, S can come in the 6th place, or S can come in the first place and P can come in the 6th place. Okay. P and S can totally form 2 number of arrangement. So we got the total number of arrangement as 10 factorial upon 2 factorial into 2. That is 10 factorial. Got it? So in the first case, we got our answer as 10 factorial. Similarly, if you take the second case, the same condition will be applicable. We are having 10 slots, we are having 10 letters. 2 slots have already been consumed by P and S. So we got our answer as 10 factorial upon 2 factorial into 2. Okay, that is 10 factorial. So we got our answer in the second case also as 10 factorial. Similarly, in all these cases, the answer will be 10 factorial. Okay. We are having total 7 cases. So the answer will be addition of all these 7 cases. That is 10 factorial plus 10 factorial plus 10 factorial, this and this. So we got our answer as 10 factorial into 7. That is 25401600. That is the answer of the question. Got it? Slightly a tricky question. We have to form the number of cases in which there are 4 letters between P and S. Okay. So have we used any of the new formula? No, we have not used any of the new formula or the technique. Just what is used? The common logic is used. Okay. We have formed the 7 different cases and we have applied the simple formula of the permutation. Got it? Let's take one more question. The question is, in how many of the distinct permutations of the letter in Mississippi do the 4 I's not come together? Okay. Pause the video and try to solve this question on your own. So let's try to solve this question. So we have to find the number of permutation when i's not come together. Okay, it is having total 4 i's. So how we will approach this question? Firstly, we will calculate the total number of cases that we can form using the word Mississippi. Then we will calculate the number of permutation we can form when all the i's are together. Okay. Then we will subtract the cases where I is together with the total number of cases. Okay, that will be the answer of the question. So firstly, let's calculate the number of permutation that can be formed using the word Mississippi. It is a 11 letter word and I is repeating 4 times, S is repeating 4 times and P is repeating 2 times. So we got our answer as 11 factorial upon 4 factorial into 4 factorial into 2 factorial. Okay, these are the total number of arrangement we can form using the word Mississippi. Further, let's take the case when all the i's are together. That will be equal to 8 factorial upon 4 factorial into 2 factorial into 4 factorial upon 4 factorial. What we have done, we have considered all the 4 i's as a one set. So we got 8 letters, okay, and S is repeating 4 times and P is repeating 2 times. Further, why we have multiplied it with 4 factorial upon 4 factorial? Because we have seen the number of arrangement that 4 i's can form together. Basically, they can form only one arrangement. Okay, whatever you will rearrange, it will be I. Okay, 4 factorial we have used for 4 i's and I is repeating 4 times. So we got 4 factorial upon 4 factorial, that is basically 1. Okay, so we got both the cases. Let's do simple subtraction. So this is our answer. Got it? So students, we have done with this lecture. For other videos on the permutation, refer our YouTube channel. We have a series of lecture under the permutation series. And also we are having the various courses on various mathematics topics using the animation and the visual tool. Yes, we use animation and the visual tool for better understanding of the concept. Refer the link in the description for the complete course on the various mathematics topic. So that's it for this lecture. Thank you very much for being with Creator Classes. Bye for now.